Oh.
I'll be right in front of you, so I'll see you because
Actually, it'll be, he does 4:30 on Tuesdays, Thursdays. So we did it last Thursday. No, there was nothing right after he left.
All right, well, I'm going to get started. You guys have a new homework assignment that is due next week. It's not really that hard, it's just, a little bit tedious. You have to work on it, step by step. It looks really awful, but it's not. Okay, you just have to work. Huh?
Is it the postfix thingy?
No, I thought about that. That turned out to be a little bit too easy. I could not really use.
come on.
I could not use some of the. I could not exercise some of the stuff that we taught. Using that one. I actually thought about it, but I could not do it. All right.
You should have an extra credit assignment.
Extra credit assignment for people who do not need it, right? That usually is the way it turns out. Okay, just want to re-emphasize the 4 no, policies of this classroom.
No kids.
No kids too. Yes. No kids.
Just say no to kids.
Hmm?
Just say no to kids.
Well, we are all kids, but we're not. Yeah. Okay. Are there any questions about the homework that is actually due in about half an hour? I accidentally put in the wrong time.
That's where everybody is.
Go over it right now.
So the class is, for the most part, still in the lab, I guess. Any questions about this one? This one should not be too hard. There's no
except for the EBX thing.
Except for the EBX thing, which we found on Thursday, and you probably was the first one to encounter
what was
that.
that actually? Was it? Because I had something where the actual Z variable from.
No, Z wasn't being changed. It stored Z into EBX and used it from there. It never changed Z.
Yeah.
That's just happened where happened the computer stored Z for the time being. It was
Right.
pretty
So
simple.
besides, some of the other registers, the compiler also assumed that some of the other registers are preserved. And David basically stepped on that one on Thursday, and I took a look at it and go like, no, that doesn't make any sense. So eventually I found out what the problem was, and I just sent an email to everyone and just reminded people, okay, better make sure you preserve, EBX2, just in case. Some people, use push A, so they preserve everything and then pop A, at the end, which to me is a little bit wasteful because that includes everything. But in this class, we are not after efficiency. We just need to make sure the program runs. Okay. Yes. Go ahead.
I could, like the last number, I could make it stop being like 1000000.
That is the EBX. Yeah. You have to read the message. Okay. I got a whole bunch of people asking me that question because.
I could like.
Well, that's because I posted this last Thursday at 9:20 because as soon as I found that problem, I posted this. To basically say EBX needs to be preserved in powers, which is the only subroutine that you have to write. So you have to make sure that EBX is preserved. And one way to do that, I even give you an example. If you have to use EBX for anything, such as in your multiplication. Before you use EBX, before you change it, you push it, and after you use it, just pop it so that you can restore the original value of EBX. We have not found, any type of problems like this, with EDX or ECX, but it doesn't hurt to do the same thing to those other 2 registers. But we haven't seen any problems with the other 2 registers. Okay. So that's why it is kind of important to kind of read my email, because there's a reason why I send you an email. I'm not trying to spam you.
So why'd you send me that Viagra email?
Oh, that one. So, any questions about this, the homework the assignment that was due today? Yep.
For some reason, compare wasn't
It should work, but it wasn't working.
I was having lots of other. I mean, I completed the assignment and that sort of thing, but I.
Did you use, when you get the result back from compare, did you use, the signed comparison conditional branch or the unsigned conditional branch?
I believe I used the unsigned. So.
Yeah, it should be signed. That's why. Because CMP because the compare subroutine returns a signed integer that can be -1 or 1. If you use a unsigned comparison, then you cannot differentiate all three cases. So I think that was why in your case it was not working. Okay. Any other questions? No other questions? Okay. So I will talk about the new homework assignment first, and then we'll kind of go back and talk about the one that was due today. The new homework assignment is called BST, which stands for Binary Search Tree. But it's mostly written in C already, so you don't have to write the entire thing. You just have to write a portion of that. So the way you do this is about the same as your homework assignment that was due today. Okay, I will give you a file. It is a tar file. It has a whole bunch of files already included. You don't have to make your make file. You just have to write the subroutine in a .s file. But this one has a little bit more involved, because I intentionally make this one to utilize the concept of structures. Okay, structs. Let's go ahead and take a look at this one. So I'll go ahead and save link as, and I'll put this into today's folder. So for those of you who want to, if I make any updates, to this whole thing, it will be in here. It will be in today's folder. It sounds really bad, but it really is not that bad. There's a lot of repetition in the program, in the subroutine.
Well, any search program is going to have a lot of repetition. Is this it? No. Is this it? No. Is this it? No. No, it's not.
It's not on this side. Try it next week.
And for those of you who have not taken CISP, is it 430 in data structure? You will see this again, but except when you see this again, it will only be implemented in C++ and not in assembly.
Yes. I'll be happy with that.
And it's complaining about the timestamp. That's okay.
So what's this supposed to do?
Okay, so this is, I just, decompressed the file. Let me bump up the font size because I know some people in the back probably cannot see everything. Okay, there we go. Okay, so we have a whole bunch of files, but many of these files are files that you create. Okay, so there's not a whole lot of source files. Let me show you the structure first. Okay, so the structure is defined in bst.h, which is kind of the convention. We have, structure, which is a value. It only has one single member I. Now, there's a reason why I make it this way, because I want to be able to change the definition of the struct in C, and you will have to make it happen so that your assembly implementation is insensitive to the addition of any members in any of these structs, or the reordering of members in the structs. Okay, does everybody understand what I mean by that? Okay, what means
one more time?
Okay, this means when you're done with your program, if I go in here and I change the .h file, which is something that you should not have to change, if I change this one and included something like this, okay, it should not have any impact to your program. Okay, if I decide to change the ordering of the members, it should have no impact to your program.
So we should do something like that program to print out the labels.
Exactly. So that's what you need to do to both of these structures.
Should we write that in C or in assembly?
You write it in C, unless you cannot do it in assembly because if you try to do it in assembly, you don't have access to the actual displacement. It's a circle. It's a chicken and egg kind of problem.
Yeah.
So you have to write that one in C.
Can we do it in C++?
Yes, you can write it in C++. You'll have to change the make file to make it happen.
Okay.
So for those of you who want to write something in C++, that's fine. You just have to.
I want to use printf.
You just don't want to use printf. That's fine. That's your choice, but you will have to change your own change your make file to utilize a C++ version of that. You can do that. Okay, cool. So are there any questions about bst.h, which is just a header file to define the structure that you will use in this program? Okay. So once again, let me just repeat that again because a few people just walked in. This is the file that you should not have to change, but I will change it before I test your program. The way I change it is I can insert new members into any of these two structures. I can reorder existing members of these structures, and your program should continue to work after I type make. Okay? So that's one requirement. It should not be difficult to do, because I have already illustrated how to make your include file for the assembly program to depend on the .h file that is intended for C. So that part is done already. So now let's take a look at the one that is a little bit more involved. We have a compare function just like before, so you don't have to mess with this one that's already written in C. And now we have add BST node, add binary search tree node. This is what you need to do in assembly. Okay?
Oh, fine.
Well, let's take a look first. Okay, let's take a look at all these constructs. Do you guys have any questions? Yep. Questions? No. Okay. So let's take a look at this line by line because we want to make sure that we have covered the topics for every single line. Some of these lines, it's a relatively long subroutine, and that's because I use one line for open curly brace and one line for closed curly brace, and that chews up a lot of lines, just for that purpose. Okay, let's go ahead and take a look at the prototype of the subroutine first. What does that mean? What is p3 here as a parameter?
It's a pointer to a pointer.
It's a pointer to a struct PST node. Okay, but the other way to look at it is an address of a pointer to a struct BST node. That's the other way to look at it. Okay?
It's an address of an address.
It's an address of an address or an address of a pointer. In C there are so many ways of looking at exactly the same thing. And the second one is just a pointer to a struct BSD node. Now this part is very important to recognize that P3 is not a pointer to a struct PST node. It is a pointer to a PST node. Okay? So that part is very important to recognize. Then we have some local variables, compare result, and also we have add here. If you don't want to use the temporary variables, which I have here, you can simplify the implementation by not having these variables. But then you have to change the logic of the program just a little bit, so that you will have to have returns inside the conditional statement, which is, I personally do not like that. But if you think that that's okay with your implementation, you can certainly implement it that way. Okay, the first part here. Okay, do we know how to do something like this? Can we compare what a parameter points to 0? Null is just 0. Okay? Do we know how to get to a parameter?
Yeah.
Now, once we can get to a parameter, do we know how to dereference that parameter?
Yeah.
Okay, so that part is good. And how about this one? Let's focus on the right-hand side first. The right-hand side is just the parameter p node. We already know how to get to a parameter from a subroutine. This is an assignment statement. We are copying the parameter p node to whatever p3 points to. And p3 is one of our parameters as well. Do we know how to do that? Can we dereference p3? I just asked a question, and you guys did not have any questions, because it really is the same mechanism as this one here. Okay, this one accesses whatever p3 points to. This one also accesses whatever p3 points to, except in this case we are storing something to that location, and in this case we are only comparing that location to 0. Is that okay? The next one, we are dereferencing, a P node pointer or a BST node pointer to only access one of the members of that structure. Do we know how to do that? No?
Well, it's in your notes somewhere. So.
Well,
The
it may
user
not,
C program in the outputted header file.
no, but in terms of instructions, in terms of assembly instructions,
Yeah.
do we know how to do this? Well, let's do it one thing at a time. Do we know how to get to P node? P node is a parameter. That's not too hard, okay? And what is actually P node? Is P node a struct BST node, or is it a pointer to a BST node? Is a pointer to a BST node, which basically is also saying that P node points to the first byte of a struct BST node. Is that right? Now, you should have some kind of mechanism to give you a definition of the displacement from the beginning of a structure to each member of that structure. Is that right? If you have the address of the first byte of the entire structure, you have the displacement from the beginning of a structure to a particular member. How do you get to the address of a particular member? You just add them. Exactly. So you add them up to become the effective address, then you can do the dereferencing. Or you can use the based addressing mode, which is a very handy way to deal with something like this. Okay, any questions? I'm just going through this line by line quickly, and then we'll go through some sample programs to illustrate at least some of these concepts. Okay. The next line is just copy and paste the code, except we deal with a different member of the structure. So that one should not be a big deal. This one is just controlling the return value, okay, because we have a return value that is specified at the end here. For those of you who do not mind having a return statement in the middle of a conditional statement, you can just load up EAX and return right there. Okay, personally, I do not like doing stuff like that, but some people do not have any objection to that. So you can certainly do that. Just return 1 at this point. Yep.
Why do you object to it, personally?
Because if I do something like that, sometimes if I change the structure of this program, I might expect the program to continue to run at a certain point. But if there's a return inside a conditional statement, it is not clear that I would not even get to a point after the conditional statement. So it's just because of that fact that I do not like to use a return or break inside a conditional statement or loop. Some people don't mind that. They don't feel there's a problem. That's okay with me too. I think Mr. Fox used return inside conditional statements too.
So you just said you should push 1 number.
Huh? No, this is just return 1.
Oh, return.
Yeah, because at the very end, outside of the conditional statement, I just return the value of added. And added also has an initialized value of 0. And there are several ways to do it. You can just reserve the space and then move a 0 into it, or you can just push a 0 as you allocate that space. So there are several ways to do this. Yep.
Do we use any operations that overwrite EAX requisitely?
Sorry?
Do we have to use any operations that require overwriting EAX in this function in this function anywhere?
Overwriting EAX?
Yeah, anywhere.
But you have to do it when you return a value.
Oh, other than that, do we have to use any other functions that would overwrite EAX?
Well, BST value, will override EAX because it is a function returning an integer. So
Okay.
that will override EAX. Okay, so the next thing is BST value compare. Do we know how to push P node on the stack? That can be done with one single push out instruction because we're not pushing the address of P node, we are actually pushing the parameter P node. So that
we
means
use
you can.
2 sets of parentheses to dereference the
P tree needs 2 instructions because you are dereferencing, but P node is not dereferencing here, so you just push P node on the stack. Then you call, and whatever is returned, there's 2 ways to do it. I have to do it this way in C because I don't want to call it again, for the second comparison. But since you're going to do this in assembly, you can just, pick up EAX after this function call, compare that to 0. If it is less than, do this. If it is greater than 0, do the other one. So in assembly, the assembly version can be simpler than this. I mean, this is actually a little bit more cumbersome than the assembly version. Yep.
So if it's 0, we do nothing?
If it is 0, you do nothing. That is correct. Because in a binary search tree, if a node is already exists to represent a particular value, you just keep that one. You don't create a new one. Okay. And you can see that there's a particular pattern to this code. This line it's very similar to this line here, except one deals with one side of the tree, the other one deals with the other side of the tree. In other words, once you figure out how to do one side, the other side is fairly easy to do. Are we doing okay so far? Kind of? Maybe? Maybe not? And this one is a recursive subroutine, by the way, because you can see that I'm defining add BST node, and it calls itself. Are recursive subroutines any more difficult to implement? They may be more difficult or tricky to write to begin with, but once it is written, the implementation is no more tricky than any regular subroutines. Right?
Right.
Okay.
Recursion is our friend.
In certain types of situations, yes. Okay, so are there any questions about this particular subroutine add BST node? No? Okay.
Can you do next Tuesday or Thursday?
It's due next Wednesday. Because Wednesday is officially the last day of lectures. So I make it due like one day. We usually have it due within a week, like 7 days. So this one has 8 days before it's due, and I think it's due 11:55 p.m. So you have the entire almost the entire Wednesday to do this homework assignment. Yep.
Can you just put it off so that it's not due until finals, so we can use it for additional study material?
No?
So that it's not due
You
until
delay
the day of the
due date so we can
finals.
use it to study.
No, you want this to be due next Wednesday so I can give you the solution and use the solution to also help you study. No? This is not really that difficult. I mean, a lot of the code is actually common. I mean, if you know how to do this, then you know how to do this part already. I mean, there's not a whole lot of variation in this code. Okay, there's another subroutine that you have to implement in assembly. It is this one here. This one is going to return a structure. So all the stuff that we talked about last Thursday, will come in handy. Okay, you will need to use mem copy to copy the whole thing to an area reserved for the return value and all that stuff. But we talked about that last week already, and I think I wrote some sample programs to do that too. So you might want to check out the sample programs that I wrote on last Thursday and make sure you understand the sample program. You can go through the whole lecture again. Just go to YouTube and go through the whole lecture again, and just make sure that you pick up the concepts and not really just not just the code, but why I do things in a certain way. Any questions about this particular subroutine? You can also do a mem set if you want to, and just change the entire structure to 0. It will do exactly the same thing. In other words, you don't have to initialize each member individually. You can just go ahead and you can just do a mem set to deal with this. Mem set is a subroutine that you can call. If you don't know what is mem set, you can always do a mem set. Fill memory with a constant byte. And in this case, you can fill it up with 0. Okay. Any questions about this particular program? That's it. Now, when you type make or make BSTC, this will give you the C implementation of the program. And it's complaining about malloc because I forgot to pound include malloc. So I have to do that first. When you see this message, you can also do the same thing. It's not a big deal. It does not change the correctness of the program, but sometimes it's just good not to. I forgot to include stdlib. That's why it's complaining. Okay, when you run the program, when you run BSTC, it will read numbers from standard in. So all you have to do is to type a bunch of numbers or create a file with a bunch of numbers. So I'll just run these numbers and type it in by hand. The numbers should not be ordered because that's how you can test whether your program is working or not. Okay? When you're done, type Control D to mark end of file, and it should print the same numbers out in a sorted order. In this case, this is where the boundary is. 53 was the last number that I entered, and the rest is the output of the program. It traversed a binary search tree to print out the numbers correctly. Are we kind of doing okay so far? Now, you don't have to have taken cisp310 to handle this program because the code is already written. You don't have to write the C code at all. But you do have to implement everything in assembly. For those of you who want to know what this program does and how it does it, a binary search tree is a fairly easy concept to understand. You start with, okay, let's deal with these numbers that I put in here. It encounters a 5 first. Okay, so the tree is empty to begin with. When you first encounter a 5, that becomes the first node of the tree. You can look at a node as a folder in a folder system. Okay, so we encounter 5 first. We create the node which is called 5. Now every node only has 2 branches. The left branch has values less than 5. The right branch has values greater than 5. Okay. So the next number that we encounter is 2. Is 2 less than 5 or greater than 5? Less than 5. So 2 should go onto the left-hand side of 5. But it's empty to begin with, so I will create a new node that has a value of 2. Is that okay? And then the next number I encounter is -5. I will compare -5 to 5 first. Which side should I go? Left-hand side. I compare -5 to 2. Which side should I go? Left-hand side. Is there anything here? No? Okay. We'll create one for -5 and make it the left node of 2. Okay. Now we move on to 43. 43 compared to 5. Which side should it go? Right-hand side. Is there anything here? No. That will make it, the 43 goes here. The next number is 5. 5 is 5. It does not get created again. Okay, so if there's a duplicate item, we just keep the old one and we do not create a new one. The next one is 1. Compare 1 to 5. Which side should it go? Left-hand side. Compare 1 to 2. Which side should it go? Left-hand side, right? Compare 1 to -5. Which side should it go? Right. Right. Okay. So the 1 goes here. And the last one is 53. 53 compared to 5 is greater, so it should go to the right-hand side. 53 compared to 43, right-hand side. There's nothing there. I create a new one. Okay. So does everybody understand the general approach? Yep.
Kind of got a question. You type in 0, 1. I think I read the 0 and the 1 separately.
No, scanf, it reads it as just 1, as a base 10 one. But this is not in the compiler. It's not compiled by the C compiler. So the prefix of a 0 means octal does not apply in this case. Yep.
Then where did the 0 come from in your output set?
Sorry?
Where did the 0 in your output set come from? -5, 0, 1, 2, 5.
Oh, it picked up the 0 as a 0, and then a 1. That must be it.
Why didn't it take the 43 as a 4 and a 3?
Okay, let me run it again. 5, 2, -5, 43, 5, 1, 53. And is that it? Yep. Control D. There's still a 0.
Maybe
So
it's
that's a
that blank
bug in my
line.
program.
Maybe it's that blank line.
Why don't you go in and do nothing?
Yeah, so there's always a 0. It must be the blank line being a 0.
Try running BSTC Control D right away.
Yeah, it will just print a 0. I think it will. Yeah.
I tried typing in an empty file.
It will do it the same way. It will do it the same because I think I read the code and then I try to detect end of file. That's okay. Your program just has to behave the same way as it is now.
Not correctly, just
so
the
it
same
is,
way.
So my bug you will not get deducted because of my bug. There won't be any points in date as long as it behaves like this. Yep.
So how does it go from there to the sorted list? You
Ah, very good. That part is done by traversal. It's not something that you have to worry about, but if you're curious, then the way it is done is, if I'm here, okay, I'm at this node here, and I want to print everything in order. How would I do that?
I would put
I
the
don't
biggest
know.
thing on the top. I put the biggest thing on the top and then stream everything to the left.
Well, how about something like this? I will go, because, okay, what is the rule of a binary search tree? Everything to the left-hand side are smaller, everything to the right-hand side are bigger, okay? So if I want to print everything in order, and this is me, I'm at the 5 node here, then all I have to do is to go, okay, I will print everything on this side first, then I'll print myself, then I'll print everything on this side. Is that making any sense?
So does it just order everything based on what side it's on?
Yeah. And then what I do is I would just, then I would go to this one here, and this guy says, oh, I'll do the same thing. I'll print everything on my left-hand side first, and then I'll print everything to my right-hand side.
Oh, that's why it's
It's recursive.
That's why it's recursive.
Yeah, and recursion in this case really helps because every node is its own tree. It has the same. It follows exactly the same rule, because every single node is a tree all by itself.
It'd be easier to do this with a class.
No, you can do it in assembly. So, are we doing okay with the general concept of what is a binary search tree? Okay. Now, how would you test this program? I mean, obviously, add node, deals with a lot of stuff. So what if you don't want to test your program, after you don't want to write the entire subroutine before you test it? How would you test this program without having to write the entire thing? What about just testing one side?
Yeah, you won't need to do the greater statements.
Exactly. You can leave one half of it unhandled just by controlling how you put in the numbers. If you put in, or the input is 5, 4, 3, 2, 1, the last one is 0. Okay, there's an implied 0 at the end because of my bug. Okay, so don't worry about that one. But if you use decreasing numbers, then it will only exercise only one side of the branch. So this way you can debug your program, because you don't have to finish the entire subroutine. Basically, a binary search tree in this case degenerates into a linear list. Is that okay? Okay. You can also just test it. It is recursive, so you can test it with just one number without doing the recursion. Just make sure that it can put the first number in first.
And with a 0.
And you have to give it an empty file, which is basically 0. Or, no, that's not true. That is not true, because if you look at the code, if you look at the code, I will turn on the line numbers. What you want to do is to test line 27 to line 33 first, without the else. Don't even try to implement the else. In other words, the tree is empty to begin with. You give it a number. It should only store that one single number.
And it'll still print it out?
It would still print out just one number. Right?
That's
Okay.
somewhere else in the code, right?
Now I can do this part here. Okay, I can comment out the rest of the program like this.
Oh, cool.
Okay, and what I'll do is I'll remake the C version. It will complain the same thing, because I did not do a pound include stdlib. Let's go ahead and do that, just so that we know how to fix that error. It's a warning, it's not an error. stdlib.h. Just like that. And then what you do is you run the C version of the program and give it just one number. You can give it any number you want. I mean, you can do 34, 42, 6, 10, and then press Control D. It should print out just 34. The very first number is the only one that will be stored in this case. So this means you can debug the program. You can write this subroutine step by step. Once you can store the first number, then you implement only one side of the branch. Pick one side, the left-hand side or the right-hand side. Okay. Once that side is working, the other side is symmetric. Okay. So I would write this program, step by step, just add one thing at a time, so that you can easily tell whether the program is working or not. Is that Okay, any questions? Yep.
So we are checking just one case of the first function, right?
Sorry?
We are checking just one case of the first function.
I'm only testing one part of the subroutine, yes. Okay, so once that part is working, then you can try to work on the second part, and you can limit yourself and block off the portion that you don't want to deal with, just like that. So this way, it will only exercise the logic of going to the left-hand side. Basically, your input, in this case, has to be like 5, 4, 3, 2, 1 to test the program. In other words, your input numbers have to be in that particular order. Yep.
That 0 that's always there may not always be a 0.
Because it's uninitialized?
It is uninitialized.
Is it because of the scanf?
You create a pointer to a struct, point
Yes.
it toward null. Then you optionally populate that pointer with data, and then you return that pointer if it's been, whether or not it's been optionally initialized with data.
No, it is always initialized.
Only if not FEOF.
No, it is always initialized. The only other case is not to even allocate it at all.
Yes, but you may return a null pointer from there.
No, it won't. If I did return a null pointer, that would have caused the program to crash already. It's basically going through, it does not recognize end of file early enough, and that's why there's a problem. So don't worry about that part. I think the last one is guaranteed to be a 0. There's no way it can be not a 0. Pretty sure.
And I'm pretty sure you're getting lucky reading random
Okay.
data and getting a 0.
Okay, so are we doing okay so far with how to approach that subroutine? Okay. Now this bug that always have a 0, I can fix that by the time I try to grade your program, because because that part has nothing to do with what you are doing. Okay. Any questions? Yep.
So how could you take apart the next one?
Sorry, say that again.
How could you take apart this one?
How can I take apart?
Yeah, to different parts so you can test it out possibly.
You mean test one subroutine at a time?
In the second subroutine, we're supposed to write an assembly language. Is there a step-by-step in that one too?
The second subroutine, there's really nothing you can break apart, because this is the second subroutine that you have to write. It is default BST node. In this one, you have a local variable n. You have to initialize all the members, all 3 members here to 0s, and then you return the structure. So if you can do one, you can do the other 2. I mean, that's the whole point. Is in this case, it doesn't really matter whether you do 1 or the 2 of these statements. Do we know how to do something like this? First of all, do we know how to allocate space for a local variable that is a structure? Yeah, because we can adjust the stack pointer, by that much space. Do we know how to get to one single member of a local variable that is a structure?
Yes. By the displacement we're going to print out.
Yes. It is actually fairly easy. This statement here can be done with one single assembly instruction. You have to use the based instruction, the based operand. But this line here, this line, and this line, each line can be implemented by one single move L instruction using the based operand. Immediate on one side and based on the other side. Well, immediate on this side and based on the other side. Okay, so kind of think about it. Okay, kind of think about this. How you can do this. Using only one instruction. If you're thinking about more than one instructions, then you're overthinking it, and it's probably in the wrong direction. Okay, are we doing okay so far with this? Is it time to write some sample programs to illustrate some of the concepts in add BST node?
Yeah.
Okay, let's do that. It's all going to be in today's folder, so make sure that you remind me to upload it, because I think this is going to be important. Unless you want to watch the video and just type along when you're watching it. Okay, so let's go ahead and take a look at a particular program first. And we'll call this the PP, because in this case we want to dereference a pointer. Okay. Okay, I'll do it this way. I'll do a pp.c. So part of it is implemented in C. The function that I want to implement, okay, include std io.h. Okay, that's fine.
You'll probably want it using namespace. You'll probably want it using namespace std.
That should not matter when you're writing in C completely. Yep. Okay, let's do it this one first. Okay, set value. We have a integer pointer p, and what we want to do is simply like this. Okay, so the question is, how do I implement a subroutine like that? Okay, that's my question. The first question is, how do we implement set value? Or if you want to know, how do we implement the call to set value? Okay, so this is the first program we want to deal with. Do you want me to interleave assembly code in C, or do you want me to interleave C code in assembly? I can do either one.
The second one.
Assembly in C.
Assembly in C, so keep this file and then just interleave assembly code?
Yes.
Yeah.
Okay, we can do that. All right, how do we implement set value ampersand x? Assuming that we do have the labels defined already. In other words, we are assuming that we are writing this in assembly and the label x is already defined to be the displacement from where EBP points to the address of the local variable x. Okay.
Eight?
Huh?
8?
It will be a negative number. In this case, it's a local variable. Remember, local variables are on the negative side of EBP, and parameters is on the positive side of that. Okay.
Would be push x parentheses percent EBP separate.
Well, we have to push the displacement first, and then we add
We want to add
EBP to where ESP points to. So this way, we'll have the address of x pushed on the stack. That's one way to do it. Then we have to call the subroutine, set value, and then we have to adjust the stack. You can use pop if you want, or you can just add 4 to the stack pointer. Either way works. That's one way to do it. Yep.
Instead of the first and law, can I use move law?
Sorry?
The first and.
The first add.
Yeah.
Instead of-
the move law instead of and.
No, because if you use a move long, it will destroy whatever I just pushed. The push instruction is not just to reserve 4 bytes. I really meant to push the value of label x on the stack. Okay, let's take a look at the second way to implement this. Okay, the second way to implement this will keep these 2 instructions because we still have to call and we still have to clean up the stack. But this way, it's a little bit more cumbersome because I'm going to calculate the actual value before I push it. So what I'll do is I'll make a copy of EBP in, say, EAX. Okay, and what I'll need to do in this case is to add $x to EAX, and then I will push EAX on the stack. So these 2 are exactly the same. They will implement exactly the same code. They will have the same effect. They will both push the address of local variable x on the stack, except one is a little bit longer, the other one is a little bit shorter, and that's about it. Are we doing okay so far? That these 2 sequences of code, even though they look different, will accomplish the same thing as far as pushing the address of x on the stack. Is that okay? Okay. So now we can move into the subroutine itself and find out how to do something like this. Okay. What is the parameter p? If I look in the stack, where parameter p is, what do I find? Do I find an integer or do I find something else?
Address.
I find an address to an integer. Okay. So that means if I do something like this, assuming the label P is properly defined, what is EAX at this point, after this instruction?
The address.
The address of an integer. The same address or the location that I want to initialize to 0, right? So how do I initialize that location to 0? Which addressing mode should I use in the next instruction? To where?
Parentheses %EAX.
That's it. Okay. Are there any questions about these two instructions? Why these two instructions will implement dereference P gets a value of 0? Is that okay? Kind of. Okay. So that's the end of this one. Yep, go ahead.
We don't trust you.
You don't trust me, so you want to run it? You want to actually do it? Then you should have told me that you want C code interleave in assembly, because now we have to do that. Yep.
Instead of the B equals 0, can you make something different so it's easier to see?
Could you say that again?
Instead of the point of B equals 0, can you set like other numbers to see different?
Instead of this, you want it to be.
No, the move 0 to the.
You mean here?
Can you move some other?
But-
Let number 5. So
He just wants a
Five.
it's
different
not
number.
0, just not.
You mean like this?
Yeah, that's fine.
Yeah. That's
We
what
don't like
it says.
Sure. I mean, you can set any value. How about this? How about I will also specify the value to put into it.
That's fine.
Well, we just made it more general. So how do we do that? Hmm? Well, ideally speaking, what we want to do is something like this, but that is not allowed because we have two memory operands in this case. So we just have to borrow, one other operand, or use the stack if you want. There are several ways to do this. We can
Just move into a register first.
Well, I can do something like this. I can push BBP and pop it into where EAX points to. That will do the same thing. This will implement, the equivalence of the C code. Right? Yes? No? Kind of?
Yeah. Yes.
Now, this is important. I'm not doing this, to make the code obscure. This is a good opportunity to make sure that you understand what push is doing, what pop is doing, and what the operand of these two instructions are actually specifying. Okay? The operand of push specifies what am I pushing on the stack, and the operand of pop specifies where am I storing that value. Okay? So these two instructions will do the same thing as the other instructions. I can give you an alternative implementation of this. Okay, move L, P to, and I can borrow a different register. But if I borrow, say EBX, I have to save EBX first. So I will go ahead and save EBX, and remember to pop EBX at the end. Now this is the way I program. You don't have to do it the same way as I do, but I always pair up a push with a pop. When I figure out that I need to push, I always figure out when do I need to pop the same thing, so that I don't forget later. Okay, so inside here I can feel free to change EBX, and the way I want to change EBX is just move L, V, EBP to EBX. Then I can just have one single move instruction at the end. Move EBX to wherever EAX points to. So these two sequences of instructions will do exactly the same thing. The first one is, just kind of more obscure but shorter. The second version is more spelled out. That's about it. Are there any questions about these two sequences of instructions and why they do exactly the same thing as far as implementing the C statement is concerned? Is that okay? Yep.
On that first one where you have the pop L, what is being popped?
What you just
It is always retrieving whatever you just pushed.
Where does it put it, I guess?
It is the parameter P.
Oh, you're
Excuse me,
popping it.
parameter V.
Okay, so that's popping into.
Right. It's just a trick, because you're using the stack as a temporary storage instead of using a register like EBX. I'm just using the stack to do the same thing. Yep.
Isn't that two memory outlets? You're accessing the stack in one EA.
Yes, but because the x86 is a CISP, it does allow you to use a memory operand when you use a push or a pop instruction. In other words, you cannot do this with a RISC architecture. With a RISC architecture, you pretty much have to do it a second way. And it's longer too. Okay, are there any questions about set value and any other questions about how we invoke or how we call set value? No questions? This is good? Okay. But instead of actually testing this program, which I think is going to work just fine, let me move on and talk about the structures first, because you do have to handle structures in this case. So let's go ahead and write a different program. We'll call this pstruct. And we'll do it in C, just like the other one. And over this one, we'll do something like this. Okay, void init structure struct x is a pointer. So we'll do something like this first, okay? And I don't even need a main subroutine because I'm not intending to actually, compile and run this code. Now let's go ahead and make assumptions that px is properly defined, as the offset to the parameter, and I also have x_i properly defined to be the displacement from the beginning of a struct x to the member I. Is that okay? That's my assumption. Okay. Okay. Let me just write it down here. Assume px is defined as the displacement from where EBB points to parameter px. Assume x_i is the displacement from the beginning of a struct x to the I member of a struct x. Is that good? Is that okay? Fair assumption? Okay. And with this one, I cannot do it in one single instruction because there is a dereference involved here. What I'll do is I'll ask you this question. If I move LPX EBP into EAX, what is EAX at this point? After this instruction, what is EAX? Give me the type. What is the type of EAX if this was done in C?
A pointer to a struct x.
A pointer to a struct x. Okay, very good. So EAX points to the beginning of a struct x. Now with one more instruction, I can finish up this implementation. Okay. How do I get to, if EAX is a pointer, it stores the address of the first byte of a struct x. And x_i defines the displacement from the beginning of a struct x to the member I of the same structure. What type of operand should I use to specify that location? A base operand. Okay, very good. And that will specify the destination or the second operand. The first one is just a 0. So the second one is going to be x_i open paren EAX. That will get it done. Is that okay? You just have to do it one step at a time. One step at a time. Okay, let's try something else. Let's try this. Okay, This is a stub subroutine, and we'll use our set value subroutine like before, except this time I want to pass the address of, okay, let's see. I want to pass the address of px points to I and initialize that to 3. How do I implement something like this? I'm not passing px on the stack. I'm not passing the value of member I on the stack. I'm passing the address of member I of where px points to on the stack. So how do we do something like this? Well, first of all, we know that we have to do something like this first because that's the second operand. When we push the last parameter first, and that's why we're pushing $3 first. What about the first operand, the first argument? How do we push the first argument on the stack? How do we calculate the address of member I that is pointed to by a structure by px? Well, first of all, I'm pretty sure that I have to start with something like this. Okay. Okay, what is this instruction doing? What am I pushing on the stack?
The address.
I'm pushing the address of a struct X on the stack, right? Are we doing okay so far? Okay. So this is going to push the address of a struct X on the stack. So now the stack pointer points to a pointer to a struct X. Is that right? Now, if I know where the beginning of an entire struct X is, how do I find the address of a particular member of that structure? We just add a displacement to the address of the struct X itself. And what is the label that I should use in this case for the displacement? Okay, so we just say add L $x underscore I to whatever the stack pointer points to, because I just pushed that on the stack. Then I will call set value, and then when I come back, I have to adjust the stack pointer by adding 8 to it, and I should change the other program because I changed the program midstream, so I have to change that back. This has to be changed because it takes 2 parameters now. I just want to be consistent. Okay. Are there any questions about this code here? Yep.
If you're going to be consistent, you want to change your function prototype too.
Sorry?
Function prototype, like 8 lines up.
This one?
Yep.
Why do I want to change
Wait,
that?
that's not where you define set value. Never mind.
Yeah. Okay. Is that okay? All right. Let's try something a little bit more convoluted, which you have to do in your own implementation. Okay. PPX is a pointer to a struct X. That's why it is called PPX. Okay. And this time we'll do something like let's do something like this. Let's assume that V itself is not an integer. It is a structure also, and it has a member called I. Okay. If I were to draw a picture of something like this, what do you think it would look like? Now. Okay. So we have PPX as a 4-byte thing because it is an address. Okay. What does it point to? It points to another address. Very good. So this guy points to another address. And what does this address point to? This address has no name, by the way. It points to the beginning of a struct X. Okay? So this points to a struct X. Very good. What am I trying to do here in C? Assuming this is valid, okay, assuming all these members do exist. Let's read only up to this part here. Dereference PPX. If I dereference PPX once, it gets to this part here. The pointer thing, the right arrow,
That dereferences
it dereferences it one more time. So I will get to not this part, but I'll get to the V portion of this entire structure. So let's just say that this portion here is member V. Okay. So that means the arrow thing will get me not to this part here. Well, the pointer gets me here, but the language will actually get to this part here. The dot I means that within this portion there is a component called I, and I want to get to this part here. This is what I want to initialize. Okay? How do we implement something like this in assembly? Now, once we have the picture, it really helps, right? Well, first of all, I know PPX is very important. Let's stick it into a register first.
I like it. I like it. Take PPX as a storage. It's got to be important. Take it.
It's got to be important, right? So we'll stick it into a register. EAX points to a pointer that points to a struct X. Okay. So we are done with the first step. We just took care of this part here. So after this line of code, we have EAX pointing to the same guy. Right? Because I just copied the parameter to EAX. If the parameter is pointing to this thing, now EAX also points to this thing. Is that okay? But I wanted to eventually get to this part here. So how do we get there?
What if we do the dereference of EAX back to the EAX?
Well, do we have to do something like that?
You gotta, I think, cast it. Is it doable? Is that doable?
You can do it. You can dereference EAX back into EAX. So you can say move EAX to EAX. So after this instruction, what do you think EAX is? What is
Points to the
EAX?
beginning of the structure.
EAX points to a struct X. Because we just dereferenced it one more time. What about the rest? Let's just say that V, the member V of struct X is of type struct Y. Okay? In other words, this part here is by itself, it has a name of struct Y. We need to make it associate a name with that so that we can refer to the label that refers to members within struct Y. Because I is a member of a struct Y, and V is a member of a struct X. And the struct Y is inside a struct V. Excuse me, the other way around. A struct Y is inside a struct X.
Can we just add the displacement between the beginning of the structure, the V, and then add the displacement of I to that?
Exactly. So this one is just X underscore V plus Y underscore I, and EAX. That's it.
You need a comment better.
Hmm?
You need a comment.
Comment?
Just in case. Right now it's just.
Okay. If I give you something like this, it would be more clear. Struct Y.
Yeah, why? Why we have a one?
We'll have K, I, J, etc. And then we have struct X here.
Has a V.
Somewhere in there is a struct
Y.
V. And it can have other stuff before, it can have other stuff after.
He doesn't want to.
Is that okay? Yeah. All right.
I don't think it'll compile now.
Because of the dots.
Too many ellipses. You're limited to one.
You cannot have ellipses in these definitions anyway. You can only use ellipses in function prototypes. Okay, but is that okay? I mean, does everybody understand the concept? Okay, yep.
Why do you not like doing things in order?
In order?
AXE, BXE, DXE, CX, KIJ.
Because I don't think in order. But is that okay in terms of the concept? Can everybody associate, why I think I have just done a good portion of your homework assignment?
Yeah. Thank you very much.
Yeah, no.
You answered both the questions.
But this is the sort of stuff that you should understand, because it really is doing one step at a time. Okay, if you look at it the first time, something like this is like, whoa, what is that? I mean, but if you think about it, it's not really that bad. You just have to think about it one step at a time. Now, what if I take this one more step and go? Okay, let me do something like this. This is the second statement, which will do exactly the same thing. Okay, we'll use set value.
Oh, perfect.
And then we'll do an ampersand here. And use a subroutine call instead of an assignment statement to do exactly the same thing. Assuming member I of member B is actually an integer, so assuming the types all checked out. In this case, how do we do this?
We just take what we have there and push it instead of moving a zero into
Well, we can.
What?
Yeah, I assumed the wrong mode in VI. I assumed I was already in cursor mode or movement mode, but I was still in edit mode of VI. Okay. Yeah, the K goes up, J goes down, H goes left, and L goes right.
Oh, that's terribly confusing.
And Control B pages up, Control F pages down, Control B pages up, Control L refreshes the
I
screen.
thought you were just using the arrow key. Like, what happened to the arrow key?
My hands is stuck, my two fingers, are stuck to the home keys, F and J all the time.
So you don't have to move.
Exactly. That's why VI is a programmer's, editor, because you never have to move your hand to the cursor pad for anything.
But I like doing that. It's
See-
a peace of mind.
See, $sign goes to the end of the line, 0 goes to the beginning, W, goes forward one word at a time, B goes back to one word at a time, slash, searches. Oh, I can do that in half an hour. With VI, it is not a matter of understanding, it's a matter of practice.
Yeah.
Yeah. Okay, so how do we do something like this? I think I can borrow a lot of the code from the example before, right? Because I just have to change the last one. Because the last one here, there's a built-in dereference in the second operand. And I don't want to do the dereferencing because I do want to pass the pointer itself or the address to the subroutine. So what we can do is to copy the first two lines because we still have to do these dereferencing of the first two lines. Except on the third line, okay, there's one more thing to do because I have to push the second parameter first. Okay, so now what do? We have already calculated the address to the beginning of the entire struct X. So we're pretty close to what we want. What else do we need to do? How about just something like this? Instead of doing the dereferencing using the based operand, what about just adding this constant to EAX? Well, I didn't do everything on the stack. I'm doing everything with EAX in this case. Okay, so what is EAX at this point after this instruction?
The address of member I, member B, and member X.
Of what
EX points to.
No, because I'm changing EAX, so I have to refer to PPX of a struct X, because we only have one struct X in this case. And what are we going to do with this pointer to member I of member V of a struct X again?
Push it.
Call a function.
No, not yet.
Where'd you find the address?
It was intended as a parameter.
Oh.
So we have to push it on the stack first. Then we call set value. And then when we come back, we just have to clean up the stack. And that's it. Yep.
Well, since we're just going to push it on the stack anyway, is there any particular reason you didn't do all that math on the stack?
Because it's faster to do it this way. Because if you do any type of math on the stack, there's an implied memory access on the stack. And that's slower than adding immediate to a register. I mean, that's really just, optimization, kind of topic. But is that okay? In terms of concept, does everybody understand, why? In terms of concept, does everybody understand why lines 60 to line 66 will implement the C version in line 58, on line 58? Is it okay? It's the concept that counts. This is not by any means the only unique implementation to do this thing. I mean, there are probably numerous ways to do it. If you don't want to combine, the XV versus YI, you can separate it into two statements. I mean, if you want to, you can just deal with one constant at a time. Of course, the comments will need to be changed. So in this case, EX points to member V of a struct X, then it becomes member I of member V of struct X. Okay, is that okay so far? Does everybody understand why I can break up, the two? Okay, combining the two is more optimized because you are combining two instructions into one, but separating it makes it more clear because we get to member V first, and then we look at member V, which is a struct by itself, and then say, how do we get to member I of member V? And so separating it has that advantage. Yep.
Wouldn't the linker optimize that for us anyway, or would it actually be two instructions that would be executed?
There's no optimization done by the assembler. If you're doing this in C, then the C compiler will definitely just use one single add instruction. But if you're doing it in assembly, then whatever you specify is whatever will be in the object file. And that's one big advantage or disadvantage of using assembly programming language is you get to choose exactly which instruction you want to use for something, and you don't leave anything to a tool to decide. Okay. So I think that covers at least, about 80% of the tricky code that you have to do. Let me see if there's any other tricky code that you have to do that I have not covered yet.
Whoops, I put a bug in there too. Sorry, whoops, I put a bug in there too.
I think next time I have to give you like a completed program and just sprinkle some random errors somewhere, and then you guys have to debug it. I think that would be good.
that was the last
Did
test.
you say next
I
time?
didn't like it.
Just have us write something from scratch. It's so much easier than trying to figure out what you've written.
Okay, so this is this is the code that you have to implement. I think we have covered everything. This looks awfully familiar to me now, and this looks familiar to me now. Yeah. This is the stuff that we covered last Thursday. So if you want to know, how to do something like that, you have to go back to the notes, of last Thursday because that's what we talked about last Thursday. That's it. Yep.
You said we had to also write the code to print out the labels.
Yes, you do. And that's also stuff that we talked about last Thursday.
Was that Thursday's log?
I think so. I can also point you to the exact link to it. Come on. I think it's in C structs in assembly language programming. And what you want to do is to go to
Finding out member
Finding out the
offsets.
member offsets.
Where is each member at the
Yep. Where's each member?
No, 2.1.
There you go. Yep. Now this one, do not do a copy and paste because a copy and paste is not going to work. Some of these underscores are intended was space, and then the program translate that into underscore.
You fixed that in class though.
I fixed that in class. Yes,
So
I did.
basically the same thing as that.
Well, everything
Yes.
that's not between an X and a member is a
Is,
space.
yeah.
Exactly.
So it's not bad to fix.
No, because it still has to play by all the rules of the assembler label.
% space s / underscore equals underscore /
In other words, this
space
should be a
equals
space, this should be a space, and the same thing for all the
/G.
other ones. But remember, you have two structures to deal with. You don't have just one, you have two structures to deal with. So you have to do the same thing for both structures, which is just a lot of busy work.
Thanks.
Hey, copy YY and then paste P, okay? If you use any other editors, let me see. Does anyone know how to do it in Nano or Pico? Does it have copy and paste?
Yeah, highlight.
I just opened it with SCP. Yeah.
Yeah, WinSCP can open the text file directly, and then you can just edit it on the Windows side. When you quote-unquote save, it is actually uploaded to the other side.
Yeah.
That works too.
Just
Does it have syntax highlighting?
No, I don't think so.
Okay.
There's other editors.
It's not a
you
big
can use
deal.
on that side.
For Nano, it has a text highlighting, but I'm not sure about the line number. I tried to find a function to turn on the line number.
Learning how to use VI is a long-term investment. I can. Well, personally, to me, it is a long-term investment. Some people can become successful programmers without learning how to use VI. But for me, it's a cool tool to use.
I'll wait until my boss says I'll pay you $50 to learn it.
More like $500. They do have really quick classes. Like 1 day, 2 day workshops to learn VI, and those are expensive classes. It will cost you a few $100. Yep.
Emacs is better.
Emacs is better because it's a memory pig. Yep.
I remember I used to use Emacs for a while, but then I got tired and switched back to using Linux for my operating system.
He's implying that Emacs is so complete, as a tool, it is almost like an operating system on its own.
Emacs is an operating system. It's got apps built in. It's got everything you need. A calculator. It even has a text editor.
It has its own scripting language, yes.
It even has a text editor.
Yep.
Emacs also has its own text-based RPG in it.
Games, apps, calculators. It's an operating
I
system.
think I can deal with NetHack, just fine. Okay, it's compiled in C. It runs more efficiently. I can get killed by killer bees, quicker.
What about those grooves?
Hmm?
What about the grooves?
The gurus.
Okay, bad joke. Never mind.
Okay. Okay, so are we doing okay with this homework assignment? Do we know what to do? So it's a combination of a lot of stuff that we have talked about over the past week and today. You might want to look at the sample programs that I captured and uploaded, last week and also today. Those should be helpful. But for the most part, what you need to do first is to understand the C constructs first. When you see something, complicated, let me just switch back to, when you see something that looks kind of awful, like, I'm trying to point to something that is really awful and I cannot find it.
Lines 1 through.
There's nothing here that is really awful. None of that is really
Anything with an ampersand and a star both kind of counts.
Passing the address of the pointer as a parameter to me was the worst part. Yeah.
You mean that part?
Yeah.
The ampersand,
but
the
asterisk,
asterisk,
okay.
and the
Now
arrow.
C does everything backwards. Okay, remember, in terms of the ampersand operator, it is actually backwards because without the ampersand, there's an implied. I need to know the address of that thing first before I can get to the value of that thing. The ampersand is actually telling the compiler, oh, by the way, do not get to that thing. Just give me the address of that thing. Okay, so adding the ampersand to something is actually making things easier because it is asking you to calculate the effective address of that something instead of getting that something.
So adding a command reduces the number of steps.
Correct. And it is backwards. It is a little bit backwards, actually.
Yeah.
So in this case, if you know how to get to, okay, first of all, you have to read this in the right order. Okay, that's the first step, is to read this thing in the right order. You start with tree. Then you say, okay, this is what tree points to. Okay, I'm using what tree points to point to a particular structure or a particular member of that structure. And what we want to do is to get the address of a particular member of a structure that is pointed to by a pointer pointed to by tree. That's basically what this statement is saying.
That's an English challenge, not only a programming challenge.
Yes, I would like to present this to an English teacher and see what is the proper way to say it.
They would just spill red paint on the paper.
I think they'll just get
so grammatically incorrect for English.
they'll get a can of spray paint.
Yeah.
Go like shh. That's their score. But when they turn in assembly programs, I can do the same thing.
I think they would just burn the paper and call it witchcraft.
I think the paper will burn by itself. You don't have to set it on fire. It will self-incinerate. But that's the whole thing. You have to do it one step at a time. Don't try to look at this thing, and go, okay, how do we do the whole thing? Just do it one step at a time. How do we get to just what it points to? Okay, once we get to what it points to, then you think about, okay, this is a pointer to a structure. How do we get to the first part or the base of the entire structure? Once we get to the base of the entire structure, how do we get to a particular member of that structure? Just do it one step at a time, and and a lot of this stuff is repetitive. Okay, I pointed this out earlier in the class already. If you know how to get this part done, you already know how to get the next line done. This one is just returning a value of 1. If you don't want to use a local variable to specify the return value, you can just say return 1 at this point, and it's done. Okay. Over here, you have, this part should not be a big problem. You're just comparing a local variable to 0. And this statement is exactly the same as this statement here, except they access different members of, what a PST node, has. Yep.
Does your makefile account for the fact we'll have to have a file that prints out our labels? Do you give us a file?
Yes, I do. Yep.
Okay.
That part is taken care of. Okay. So the makefile is already done. Let's see it on. Okay, so it's already done. This is what you have to do to debug your program. BST is the program that has your implementation of add BST node and your implementation of default BST node. Okay? And then when you look here, add BST node depends on add BST node dot uppercase s and also bst.inc, which is the include file. The include file depends on BST struct, which is the same as x underscore struct that we talked about last week. And the way you create the include file is just to run this program and redirect it to the file called bst.inc. And BST struct as an executable depends on bst struct.o, and the dependency stops there because it knows how to generate the .c file. It knows how to generate the .o file from a .c file, so that rule is implicit. We don't have to specify it. Okay, so that means, and that's it. A stub of that is already done for you. Okay, this is the stub of BST struct. Obviously, it doesn't do what needs to be done.
So this is where we print out the labels.
You have to populate it with a bunch of printfs to print out the labels. Yes. If you want to do it in C++, you can, but you have to change the make file because GCC can only compile C programs. You have to use G++ to compile a C++
since there's
program.
that page back there with all the printouts already, I'll just do that and change it.
Exactly. You can just copy and paste. Change all those lines. Yep.
And you said there was 2 structures, so we have to implement it twice, but label it with a different structure.
No, just use this to print out.
Use
all
one
the
single
labels.
program to print out labels for both
For
structures.
both structures in one
Correct.
thing. Okay.
Yep.
Don't we also need to include the structured files in that .c program?
Yes, you do. You have to do it.
Okay, just making sure.
Yep. Yep.
And you need 2 different offset functions, or offset macros.
Oh, well, I forgot one thing here. Okay, what I forgot was this. Okay, I really should have spelled this out because I can change the header file. But as far as you're concerned, because you're not going to change the header file, there's no impact to you. So it's just that when I grade this program, I have to move certain files from your folder into my test folder before I can actually test it. That's all. It doesn't impact you guys. I mean, it impacts how I grade it. Yep.
And so when you said you could add members to the structure or it's not going to affect ours because we're only looking at certain members. within the
Exactly.
structure.
If
The
you
other
do it
structures-
correctly, then it should not impact you at all.
Okay, they'll just be somewhere else that we're not worried about.
That is
The
correct.
offsets we don't care.
Okay, because when I add buffer as a member to value struct value, if you have been using, value underscore I as a displacement, even though it was 0 all the time, then it doesn't bother you at all because it will be automatically updated because of your C program. But if for people who did not do that and just shorthand everything and just say, oh, by the way, value only has one single member, so the displacement to that member has to be 0. I just will just put a $0 whenever I expect that label. Then those programs would not work correctly when I do something like this. So it's basically just a test to make sure that people understand the concept behind the whole thing and be able to go through the whole procedure to make sure that they can write assembly code that is consistent with the C version of the same code. Any questions about this one? I think the actual writing or the actual writing of the code is not going to take much time. Most of the time will be spent debugging.
Yeah.
Okay. Now you guys know this already because most of the homework assignment that we do now have some kind of pointers, have to do with a stack. If the stack is not balanced, it will return to La La Land. The whole thing will just crash. So what it means is write very simple programs. Okay. Do only a few steps. Simple steps at a time. Check that your program is working, and then move on and write some more lines. Okay, don't try to write 20 or 30 lines at a time and then make your program work that way. Write smaller numbers of lines every single time. Revision control also helps, just in case the program is partially working, and then for some reason after one change the program did not work at all. Then you can compare to an earlier version and find out what you changed to make the program not work at all. Then you can go ahead and revert that change and start from that point. So make sure you make a lot of backups. You don't have to use revision control. You just have to save the file using a different name. That's one really rudimentary way to back it up, but it works as well. Okay. Any other questions? Oh, the other trick, if you want to back up all the files, if you want to take a snapshot of all the files and you don't want to learn how to use RCS or something like that, you can just tar it, make tar.
Oh.
So what you do is you just say, make tar, and observe where the tar file is located. The tar file is always at your home folder. Change that file to a different name. So that way, when you say make tar again, it doesn't overwrite the same file. So this way, you create snapshots of not one single file, but of the entire folder. Just little things that can help you in the process. So if you do something like this, then you have to go back to the home folder and then just copy BST answer to BST, followed by today's date maybe. Okay, so you just say 2011-0503.tar.gz. So this way you know what this file is about. Okay, but this is a fairly good way to do it, because it backs up not just a single file, it backs up the whole folder. So you cannot say, oh, I forgot to check in that file into the repository. Well, the whole thing is checked in. Okay, any other questions?
Practice final? Practice final?
Practice final will be next Tuesday, because we won't have classes on Thursday. Thursday is the first day of final exam.
And our final
week
is
from
the
now is the
following
last day?
Tuesday, right?
Yes, our final exam is the following Tuesday.
Do you know how much time we have for it?
2 hours. It goes from 8 p.m. to 10 p.m.
So
Yeah.
it's really going to be like 3 hours.
It's in the lab, right? Not
It is
here.
in the lab. Well, I would try to see if the lab,
Oh god, the paper one was awful.
I don't
No more
know. They were
paper.
both horrible.
I'll think about, I'm even inclined to use, multiple choice questions.
Give us code. This code is a sample of code, not the complete program. Which of these following
I can give you
answers
like
is
code,
right?
I can make multiple choice questions. I can give you like, as a program, and I will give you the C version. I will give you my implementation in assembly, and I will ask you what is the first line of error, what is the first line that needs to be fixed in this program, and you have like 20 choices or something like that.
One for each line.
Well, I mean, it's multiple choice. You can just fit each line into the program and see, okay, is that the first line that has a problem?
The probability of my guess goes down as the list goes
Yep.
After you give out the practice exam, will you be doing a video for solutions for that?
You mean for this assignment?
No, for the practice exam you give out on
For the
Tuesday.
practice exam. But we'll talk about the practice exam face to face.
Oh, okay.
So that is already going to be recorded. Yep. Any other questions? Yep.
So the final is gonna be.
Comprehensive.
Impossible.
I did not say that. I did not say that. Yes.
So the final is gonna be the week after next week, right?
Yeah,
It will
we
be
can-
it will be Tuesday after next Tuesday.
2 weeks.
Okay.
weeks from today.
2 weeks from today.
It will be about yes, it's 2 weeks from today.
Yeah.
It's the last day of all final exams, I think. Yep.
Okay, can you know in advance if it's going to be on paper or in the lab?
I will confirm maybe next Tuesday. You know, I have to see whether the lab is open at that time. I think the lab is available. Nobody is going to go to the lab and do anything the second last day of the whole semester. So we can probably do it at the lab. If it's multiple choice, you know, whether it's on paper or not really does not matter. I mean,
Not true.
Not true.
If it's multiple choice, but we can plug it into the compiler and see how it runs.
oh, that's right.
You should create 2 different finals, grade them separately. Let us do one, the other, or both, and pick one to turn in before we're done.
Yeah, you guys will get your grade next year.
That's all right. I don't want to see it anyways.
Okay, so is that okay? I mean, it's a homework assignment, okay. Does everybody know how to get it started and what material you have to review or you can review to get this one done? Is that okay?
This one will be easy.
Okay. Well, I wouldn't say easy, but all the stuff is there. I mean, there's all the material is online. I'll be at the lab.